So fed up with Streamlabs. Part 2 for the entire video was muted. I never muted it. It was muted. Streamlabs muted my audio somehow remotely because when I was playing the video back to check it, there was no sound. So everything I was explaining went into the ether. So let me just go over this again. I've got to do this all again now because Streamlabs has got a problem with their flipping menu. When you do something, it should say, "Are you sure?" It should ask you, "Are you sure you wish to mute yourself?" Right, let me go over this again. Right, so as I was explaining in the previous video, the coil arrangement, I was originally going to put in the previous, if you go and watch part 1, I was going to put the trigger coils on these quadrants. The quadrants being the fact that when you look at the coils, the magnets, sorry, you'll notice that we're actually moving from one top dead center to another top dead center. You don't want to go the whole distance because otherwise you get drag. So basically, when we turn the activation coil on at the bottom, we want to be turning it on basically just after top dead center. Otherwise, you're just wasting energy because you're just pushing laterally or vertically against the axis of the rotor instead of moving it. So what we do is we create a slight delay. I cut this out earlier so we could make it easier to show. So as this is rotating, as it rotates, oh, it's going that way, we actually have maximum torque. So that as this goes round, we want really the ideal position for torque is right in the middle of the two magnets because you're pushing on this and pulling on that. So it's a tug of war that's in unity and balance. However, you can't. There's a small area in between those two. You don't get a great deal of torque. You get a lot of torque there, but you're only about 5% of the whole rotor's distance. So I mean, there's actually 10% because you're doing the opposite side as well. But anyway, so what happens is you want to trigger it slightly delayed, so you want a slight retardation. So it triggers slightly just after top dead center. So I've got my trigger coil in the same place there, but I've tacked another trigger coil onto the top of this one. So if we go back to the device, I've actually put the off coils, which are very thin coils. They don't need to be great. So the generator coils are underneath the concentric magnets arrays. So I've got two trigger coils and they're both wired in series, but obviously the polarity is different, so the polarity reverses because this one might be south below and this one might be north, but we want the same. We don't want them cancelling each other out, we want them to be in unity so they're in series and pushing a DC voltage out for the signal. So these two trigger coils turn it off and come down to through the circuit and basically actuates our cycle, so that we have an on and an off cycle that's controlled mechanically by the actual unit itself. I've been doing some tweaking actually since I made the last video that they had no audio on it, and I actually added a capacitor onto the MOSFET driver circuit. I repaired it, by the way. I put a brand new ordinary MOSFET in. I didn't have a service mount one, so I had to tack another one in. This thing got destroyed previously, so I repaired that. I stuck a 220 nanofarad capacitor across the MOSFET, across the coil basically, and that improves the speed, and it also nulls out some of those horrible nasty spikes that you get from the back EMF of the coil. Sticking a diode across it, bad idea, it just slows everything down. So a 220 nanofarad seems to be just right, at least in my situation with my coils. It depends on your coil setup. Anyway, the unit works pretty well now, and I've even got my current down to 520 milliamps. Mind you, we're driving we're driving this out to 19 volts right now. That's because my two coils are in series. Well, I want to rewire them. They're actually in the bottom right down there that are driving everything. I need to take them out and rewire them in parallel. The current's probably double. It'll probably double up to about an amp, but it's very stable. It's got quite a lot of torque. But by having it at an amp, it means I can drop my voltage. Instead of having 19 volts, I can run it at, say, 9 volts, which is better than before, because the previous motor I was running, which was in this housing here, it used to draw about 1.3, 1.4 amps, which is a lot more than what I'm actually drawing right now if you work it out. Do the math. Right? I'm not good with math, but you can work it out. So anyway, so the signal is working very well. I've actually got more charging current now than I had before. So actually, when I was using the rotary magnet, I mean, sorry, the motor that was in that housing there, I was driving it by belt drive. There was a lot of loss in the friction of the belts, and there was also the noise of the other motor as well. It was very noisy. It kept overheating, the flipping thing, and it was driving up the wall. I just wanted to go to the direct drive, but I was just trying to put it off, really, to be honest with you, because I was trying to work on the generator side. But somebody talked to me, a friend on Discord, about why do you drive it? And I was thinking, I don't know. I just told him that basically that comes later. But then I was thinking about it. I thought, well, actually, that makes sense, because if I'm going to direct drive it, then I could use the circuit at some point to send pulses into the system to cancel the drag anyway. So it actually might be beneficial. So previously, when I was showing the part 2, we had 580 to 600 milliamps consumption. Now it's down to 530 milliamps, and it's actually running faster. So let's have a look. So at 5,345 RPM, and that's my output at the moment. The output on the blue trace is simply the exit coils, which is the drag cancellation coils, which are actually in the bottom down there. They're actually in series with this circuit here, which is basically quite primitive, really. It's using some delay line chokes and everything, but I really want to get away from that. I want to be able to directly time those pulses so that it goes to cancel the drag at the right moment, and that's probably another reason for this circuit, because this circuit gives me that ability to make a variation on this circuit, so I can actually send pulses and negate some of that drag, you know. But anyway, in the meantime, I'm worried about part 1 now. I'm starting to think, oh, maybe part 1, maybe that was got no audio. Oh no, I hope there's audio in part 1. Otherwise, I'm gonna have to do that as well. Anyway, maybe I won't bother. I'll just check it and see if it's working. But I'm very annoyed when these things are muted and they don't tell you. Mind you, it probably had some notification on the screen somewhere and I just didn't see it. Ah, there's a little green thing there. I don't know if it's Wi-Fi or audio, I don't know, but anyway, I'll have to pay attention to that in the future. So that's where we are at the moment. There's electrical tweaks I can make to my circuit. I said earlier in the part 2 that it had no audio, which you didn't hear. The circuit works very well. Well, it does, but there's always room for improvement, and there's a few tweaks I can make to the drive circuit to optimize the current consumption, because you can do a little bit of wave shaping on it to, yeah, drive the MOSFET more efficiently and keep the current. That's what I just adjusted this trimmer earlier by turning the gain down slightly. My MOSFET's running even colder now, and it's actually running faster. So yeah, there's always room for improvement. So that trimmer's at the maximum range. It's a 1K trimmer. I'm gonna have to dig out a 20. I've got a 22K. I'm gonna stick that. I'll probably stick that in and try that. But I can't turn it down at that point too much, because the more you turn it down, the harder I have to work to start the thing going. You know, when it's at a standstill. Anyway, enough of that. I'm gonna go and check part 1, see if that's got audio on it, and so I don't know. Hopefully it has. And then we'll just carry on with some more updates over the next few days or weeks, whatever. Yeah, there's some more things I want to try out. Yeah, I mean, I haven't correlated them in my head properly yet. They're all just random ideas, so there's no point in talking about them really. But yeah, I'm glad that I've got that many blooming parts now. I've got all these coils around for the previous generator, which is over there, and I'm dismantling it at the moment because I no longer require something so bulky and large and inefficient, because it was inefficient. And because I've built these coils for that previously, it's nice to be able to repurpose them. I mean, I don't need much power to drive this circuit. It just requires a signal, and those coils were perfect. And I was thinking about using some Hall effect devices, but the trouble with Hall effect devices, you need op amps. You've got to amplify the signal. You've got to fart about with that. Then they require power to drive them. But at least with these coils, it's self-generated. It produces its own voltage, its own pulse, and then, which means I can keep my circuit even smaller. And they don't really induce any drag on the system because they're on the opposite side of my concentric magnets, which basically these things negate a lot of the drag on the system anyway. So it's like a firewall basically. In magnetic terms, it balances the flux out, evens it out. Anyway, that's it for now. I'm just going to watch some snooker and yeah, and think about things. I'm glad I was able to get this repaired. I didn't have a surface mount MOSFET, so I just dug one out of my drawer and I stuck that on and glued it on as well with some thermal heatsink stuff plus a bit of ABS plastic so it wouldn't fall off. It stuck onto this shared heatsink with this other boost converter at the moment because I didn't want the thing to fry, because I'm not sure if the previous one overheated and basically fried. I don't know. It just failed on me. I don't know what reason it failed on me. All I know is it's in the bin right now. Anyway, this one seems to work. I'd rather use this circuit board because it keeps the noise and the pulses isolated from my driver circuit. These MOSFETs generate, because they're inductively coupled to the coils, generate massive spikes, and those spikes get back into the circuit. But because this has got a separate voltage and it's opto isolated, which is this thing down in this right down there, you can't really see the LED shining in your eyeball. Block this LED out, you can probably see it, but it's right underneath my my brush thingy. Anyway, so yeah, this works pretty well. If it ain't broke, don't fix it. So I'm sticking with that, and for now, and it means that I don't have to rebuild a whole when I rebuild a new circuit board. The previous one I built was this one, and it was, yeah, it works, but it's not very ideal. It's not. There were some issues with it, so well, that's what I made. Anyway, I'm going to redesign a new one and get that one etched to put that on. This is very simple. It's also got opto isolators in it, which I used, and I'm going to recycle all this stuff. I'll just take them off the board and reuse them all. Don't waste anything. For example, I've got some old boards up here. Look, this is an old board I never actually drilled. I drilled that one, but I never actually ended up building it. But I've got some other boards which are just covered in solder where I stripped all the parts off them, you know. Anyway, I think that's enough for now. Thanks for watching.